Hello guys, welcome to another video. And this video will discuss more of the angle bisectors that we should have finished last class, but totally fine. So the purpose of this video is to find the missing length of a triangle by using the angle bisector theorem. Now we did discuss this in class, but in case you've forgotten, I brought in a special guest to give a little recap of what we did in class, so the construction, the proof. He understands how far we got, so don't worry about him not knowing how far we got. So he's a very busy man, so I hope you pay special attention to him. So let's hear from him right now. Howdy there, folks. My name is Mr. Garmer. My grandpappy's name is Mr. Geometry. My pappy's name was Mr. Farmer. That's why they call him Mr. Garmer. Now, folks, Mr. Garcia, a fellow I'm very fond of, is a man who always frequently visits my establishments, has asked me to come here today to help you guys review this little thing called an enchanter. Now, if you guys didn't know, I'm a very busy man. Very busy man. I own a lot of local real estate around town. I own a farm. I own a wildlife exhibit. I own a museum. I own a haberdashery for my kangaroos. We also sell some famous miniature pizzas as well. Now, I had to bring in some of my animals today because I couldn't keep them at the zoo. And I couldn't keep them at the wildlife exhibit. Can't keep them in the museum as well. So they may interrupt. So look at this cat. This is one of these big cats. You know that Joe Exotic fella? I'm the original Joe Exotic fella, except that I'm not a creep. Now, we have one of these big cats right here as well. We have this thing that was lost, but I found it. Again, we have one of these small cats. Nothing too crazy about this one. And then I'm getting sick and tired of all these rodents running around my place. I'm sick and tired of all these rodents running around my place. But hopefully they won't disturb us today while I just do a quick little review. Now, last time, y'all did this little thing with this little pad paper contraption. Incredible, isn't it? You can just see in all different directions. Now, with this here, y'all took some angle. Man, that's too small. Let me get a bigger one for y'all. That's a little bit better. Y'all took these angle bisectors. It's in all these three parts right there. Those three parts. And y'all took them angle bisectors. Y'all said that those two angles are the same. They're the same measurement because that's the definition of that angle bisector. And now, if you said that all three of those fellows meet at that point. That's called the in center, not the out center, but the in center. And I also said one other thing. That said that this distance is going to be the same. How do we know it's going to be the same? That's the definition of the in center. Remember we drew that little. We didn't do it. Y'all did it. Y'all drew that little circle with the compass. Yeah. So that's what that was right there. Now, folks, I want to keep going with this, but this is just a little bit. This is just a little review of what was going on last class. And now today, Mr. Garcia informed me that y'all gonna do some practice, some practical practice with all. Sorry, folks, this chicken is annoying. Y'all gonna do some practical practice today in a bit. So, thanks for y'all for listening and tuning in to me. You can catch me every single day, 7 a.m. on radio, 1-800 Fox FM. So, folks, I will see y'all later. Wow, folks, what a very special guest we just had. Thank you again, Mr. Garmer, for coming out and just helping educate the youth within your farm animals and the wonders and beauty of geometry. So, if you have any questions about Mr. Garmer's policies or times, stuff like that, direct them to him. I believe you can find his website just by Googling it. Now, just a little reminder of what he said the angle bisector, that was just dividing the angle into opposite sides into two segments that are proportional to other sides. Again, we're saying that they're the same length or same measurement. And the end center was where they all intersect. So again, we drew that little circle last time to show that it's going to have that same radius, which meant those inside pieces were all going to be the same. So some practical examples. Last time we did a proportion example. We have another one like that. So given this triangle here, again, it's just some triangle, we need to find the value of x. If you notice, the value of x is a sine length CD. So again, when approaching these questions, it's best to set up a proportion. And you're going to match up the sides with the sides. So let's look at this angle right here. I'm going to match up these sides together. And then if you look at this angle, I'll match up these sides together. You're going to pen out, perfect. So then I want to match up the sides AB and AD. Again, they're both on the same side of that angle that's being bisected. And then do the same thing on the other side. Notice I did side AB. Therefore, I should probably do side, I'll just say BC. BC. Same thing, if I did side AD on bottom, I probably should do side CD on bottom. Right now, I'm not too worried about like naming sides of a triangle. We can get to that at a later point. We probably won't have enough time, which is totally fine. I'm just primarily concerned about setting this up. So again, I looked at that angle B and I saw that it was being bisected. Again, these were the same length. This is an angle bisector. And so that told me that, hey, this can be proportional to this side, just by definition of angle bisector. Now with this here, I'm just going to plug in what I know. So I know that side AB is 5. Side length AD is 3.5. BC would be 12. And no, CD is X, which I'm trying to find here. Again, set up what you know, and then from there, remember that little trick we did? Not trick, but the kind of method we did last time? It's cross multiply. We had two proportions set up on either side of an equal sign, so we need to cross multiply. So 5 times x is 5x, and I have a calculator here. We'll do 12 times 3.5, which is 42. And with this here, oh, that's not good. With this here, to solve for x, we're just going to divide by 5 on both sides. Now, yes, 42 over 5 does not reduce anymore. For the purpose of this example, I'll go ahead and say 8.4, solely because that's like it's a nice decimal that's finite. Either way, those are still the same answers. So again, we set up a proportion to help us find the missing side. And it's so important that you set up the proportion correctly. Because if you do not, you're going to end up with a missing side length. You can refer back to last class where I showed an example of a bad proportion to set up. That's one way to solve these. What if I just told you this? I said that MR, so that's ray MR, is the angle bisector of angle NMP. We need to find a value of x if angle 1 is 5x plus 8 and angle 2 is 8x minus 16. So go ahead and pause this video, see if you can figure it out. Welcome back. So with this here, to find out what is the value of x, read it again. It says MR is the angle bisector. Think back to what that means for angle bisector. Correct. That means that the angle it bisects, that says that these two would be the same. So that we can basically now say, my bad, we can say that measurement angle 1 is going to be the same as the measurement of angle 2. Again, since there is a bisector, it tells you that MR, the ray MR is your bisector. That says that those two angles will actually be the same measurement, which is good. Because what is measurement of angle 1? It is 5x plus 8. And what is the measurement of angle 2? Well, it is 8x minus 16, which is nice, which is good. So with this here, again, I'm just trying to solve for m. Doesn't really matter what I do first. I would tend to want to keep a positive. Again, doesn't matter. People like to have your variables on the left. It's just up to you at that point. But I want to keep a positive x value. So I'm going to move that 5x to the other side. And I won't do multiple steps here. I'll do it one step at a time. 8x minus 5x is 3x. And I'm trying to solve for x. So do not divide by 3. Go ahead and add 16. So we get here that 24 is equal to 3x. And then here to solve for x, we're just going to divide by 3 on both sides, which means that x is equal to 8. Now again, my goal was just to solve for x, which was good. And then from there, I'm set them equal to each other. So a way to test yourself that you're correct is if you wanted to, you can plug in the value of 8 right here and plug in the value of 8 right here. If you get the same result, which I just did if you saw me looking down, you should get 48 for both of those measurements, which is true. So let's try another example like that. Go ahead and pause the video and try this one by yourself. Pause the video. So with this here, we need to find the value of x. And they give us the measurement of angle 2, and they tell us the total measurement is 59x minus 1. So given this, we know the following things. Measurement of angle 1 plus a measurement of angle 2 is going to be equal to that total measurement, right? How do I know that? Well, I mean, that's what the picture is telling us. They're saying that the measurement, so they're saying that angle XVW is split up as two separate angles, angle 1 and angle 2. So that's just going off of the definition what it's giving us here. Now they tell us a couple things here. They say that measurement angle 2 is 1 plus 28x, and measurement of XVW is 59x minus 1. Cool. Well, we almost could have done the same thing as last time, but what about measurement of angle 1? They don't tell us that in the statement. Think about it. Remember, we're going to go ahead and say that measurement 1 and 2, I probably should include that in the directions. I didn't say that. That's on me. But we'll say that 1 and 2, it has an angle bisector. So if I want to go ahead and say this, VP is an angle bisector, which is good. Since that ray VP is an angle bisector, that says that these two angles are going to have the same measurement. So if I say that the measurement of angle 2 is 1 plus 28x, that means the measurement of angle 1 is also 1 plus 28x, which is good news. So with this here, what I'm going to do is just plug in what I know. So I know that the measurement angle 1 is now 1 plus 28x. And I also know the measurement of angle 2 is just 1 plus 28x. And yes, you could have put like a parentheses and a 2 on the outside. Either way, you still do the same thing. And I know that the measurement of angle XVW is 59x minus 1. That's good. That's nice because now I can just simplify this by combining like terms, moving my x around, doing what I need to do. So on this left side, let me just combine like terms real quick. So I want to combine these x's together, and then I'll probably want to combine these ones together. Obviously, we know 1 plus 1 is 2. 28 plus 28 is going to end up being 56. Minus 1. Perfect. So with this here, again, doesn't really matter what side your x phi is going to go on. I'll just do the same thing as last time and move my x to the right-hand side. So we'll subtract 56 from both sides. Perfect. So we get here that, oh, that's not good. We get here that 2 is equal to 3x minus 1. And then from here, this is a lot less intimidating, isn't it? Add 1 to both sides. And you probably already know the answer right away. 3 times a certain number will get you 3. I wonder what that number is. Turns out that number is just 1. So quick little recap again. We need to find, and I should include this, so that's on me. Find the value of x if the measurement of angle 2 is 1 plus 28x. And measurement of all of this here is 59x minus 1. Well, according to the picture, angle 1 plus angle 2, that's going to be all of this. They just split up angle XVW into two separate angles. And given this statement here that, hey, VP is a bisector, an angle bisector, that means that these two angles will have the same measurement. So since they have the same measurement, I could just say, well, if angle 2 is equal to this, that must mean angle 1 is equal to this. And then from there, I just plugged in what I knew. With this next question, we won't really do the same thing. In fact, we'll bring it back to what we know about Pythagorean theorem. So there's a reason why I discussed Pythagorean theorem with y'all. So with this here, it says that Py is 2 and HP is 3. We need to find HY. There's a lot going on here. But doesn't this triangle look like our patty paper construction? I mean, we have an angle bisector here, 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 and they're all meeting at a point, which is called the end center. So this looks just like our construction that we did. Now, the cool thing with this, again, that it tells us, let me get a different color, that this angle, and this angle are all going to be the same length. And so when finding the value of HY, I'm going to go ahead and provide a close-up picture of just this part here, so that'd be easier for you to see. Okay, so they give you that the value, I'll do it in, we'll do it in green, that's fine. The value of PY, so this little side right here is 2, and the value of HP, so HP, this diagonal length right here, is 3. And we need to find the value of HY. What do you notice about this triangle here? We have a right angle right here. And so when we have a right angle and we have a sine length missing, we can use Pythagorean's theorem. So I'm going to isolate that triangle again, and I'll draw it for y'all here. Not the best, but it's okay. Again, we got a sine length of 2, 3, and the value of x. So with this here again, we can use Pythagorean theorem. Let's move my person out of the way. What's up? There we go. So we have here that a squared plus b squared equals c squared. And if we remember from our rules, c is the hypotenuse, which is always opposite of the right angle. So that means here that c must be 3. Now, a and b doesn't really matter which one we say is which. We have to just pick one at this point. So I'll just say that a is the value of x, b is 2, I'll go and do parentheses, and c is the value of 3. And x squared plus 4 equals 9. So with this here again, I didn't really matter which one you say a and b is, but you must say that c is your value of 3. And this just becomes a normal question like we did last time. So with this here, we want to solve for x. So we get here that x squared equals 5. But then we're like, oh, okay, that's nice. So that means my value of x is 5? It does not mean that. Because I have here that x squared equals 5. So to get the x by itself, we're going to take the square root of both sides. And if you type that in the calculator, you see that you see that square root of 5 is not a perfect square. And you won't be able to reduce that anymore. Now, I said that x equals the square root of 5. We know that x is the same thing as hy in this case. And just so I'm not a hypocrite with my words, we'll say that. Perfect. Biggest thing here again, establish what you know about the picture. So we knew there was a right angle there. We knew that that was the end center. But more importantly, we knew to use Pythagorean theorem. And so we saw that our value C must be 3. Didn't really matter what was my A value or B value. And then from there, we reduced it as we went. So we get here that PT is 5, FP is 7. We need to find FT. With this again, I'm providing more close-up pictures so you can see it better. So, and I'm just going to plug in what I know here. So I have here that the side PT, and that's kind of hard to see, but that is my point P. So PT, different color. PT is going to be 5. Oh, yikes. That's not bad. And FP is going to be 7. We need to find the value of FT. And so if I was to draw that picture again, that's not too bad. Okay. Look at that. I'm an artist at work. We see that this is a, that's supposed to be a right angle. That's like a rectangle instead. But we see that that is right there, a right angle, which is great news for us because we have a right angle and we have a side length missing, which here is X in this case. And we have here a value of 5 and a value of 7. So we're like, oh, same thing. Pythagorean theorem. We know that a squared plus b squared equals c squared. And we know that, okay, a and b can be either x or 5. Doesn't really matter. For the sake of whatever, I'll just say that a is x and b is 5. But c must be 7. Why? Because c is my hypotenuse, and hypotenuse is always across from the right angle. And this is nice because we get here that x squared plus 25 equals 49. And then we just do some algebra right here. So let's subtract 25 from both sides. We get that x squared is equal to 24. And then we're like, we're done. We're not done. Remember, we want the value of x, but we have the value of x squared right now. So to get the x by itself, we must say that x is equal to the square root of 24, but we're like, wait, square root of 24, that's not a nice whole number. It's not a perfect square. Totally fine. The last one, we had the square root of 5, which could not be reduced. But the square root of 24, let's see if we can reduce that. So again, we need to create a prime factorization tree. I want to break that 24 into its prime factors. So two numbers that multiply by 24, got plenty of options, 6 and 4, 8 and 3, 12 and 2. I'll just say 8 and 3. Doesn't matter what options you start off with, you always end up with the same answer, which is cool. So can I break up 3 anymore? I cannot. What about 8? I can break up 8 as 4 and 2. Okay, 2 I can't break up anymore. We're done there. 4 we can break up as 2 and 2. And then we're done there as well. So the purpose of this, again, was to break up 24 as its prime factorization tree. That means I can do 2 times 2 times 2 times 3, and I will get 24. Because those are all prime numbers. Now with this here, again, we're looking for groups, and then we're going to box up everything that's remaining. So when I'm saying the square root of 24, I can also reduce that as 2 times 2 times 3. Whoa, how did I get that? We took every pair and we placed them on the outside. And then we took all of our numbers that are left over, so numbers that were boxed up, and we placed them on the inside. And then with this here, and then notice again for the pairs, we took only one. We didn't take both of them on the outside. We can say that square root of 24 is equal to 2 root 6. If I want to stay accurate, I can say that, hey, ft is 2. Wow, that's a bad root sign. My bad. A bad square root sign. 2 square root of 6. I think I have one more. Can't remember. No, that's it. Cool. So that was it for this video. Again, if you have any questions, please let me know. But we'll be discussing a little bit of this in class as well on Thursday. I will see y'all then.